deposition. It's, you know, sedimentary rock is where it's layered because it's deposition. This is basalt that came out of a volcano at some point, so it was liquid. So it doesn't have any structure one way or the other. It's a mass. But if you look carefully here, you see these lines, parallel lines. And if you've ever cut a piece of wood, that's what happens. Is every pass is going deeper and deeper, and that's exactly what we're seeing. So this is 7 out of 10 probably on the Mohs scale, 10 being the hardest material, which is diamond. And so if they were able to cut that, how were they able to, they would have had to have had metal or some material harder than the material itself. And how did they have that? When you see in the museum bronze chisels and stone hammers, you need tungsten carbide or something, or diamond in order to be able to efficiently cut. And also, I don't want to talk for Chris, obviously, he's the engineer, but if you look at the distance between each one of these lines, that shows you the feed rate or the cut rate. And that's like at least 2 or 3 millimeters, it looks like, per slice.
The bronze saw, like it wouldn't last very long.
No, and the trouble is that even when they say, well, they had diamond dust or something, how long is the diamond going to be caught by the cutting teeth before it's pushed out of the way? Then you have the bronze trying to, and it can't.
Maybe the laser.
Sorry?
Maybe the laser.
No, not laser, because that's what, I actually, technically, I sent a piece of Puma Puku stone to Chris, which he took into his lab, and they used a laser to cut it. And laser is light, so what it does is it makes a real mess when it's cutting because it's liquefying the surface. So it's not a finished cut like that. No, not like that.